Well, thanks so much for the invitation, Patricia and Nora, Betsy, and Brian. Brian and I have been friends for many years, and he is really one of our best collaborators when it comes to the book presentations that we've pulled together. He's always the first one to get his chapter done and cooperates with us throughout. So when you get the signatures, you need to get some of Brian's here too, and also Tim Volk and Lou Licht made contributions to that book. So it was a team effort. It's really nice to see a lot of you who I haven't seen for a while. There's many in the room that I have crossed paths with, and I enjoy seeing. It's a lot of fun for me to come to these. My first job in Poplar was in 1963, and I've been one of the fortunate ones because I have been working in Poplar my entire career since '63, and I've traveled the world as a Poplar and Willow scientist. So I feel very fortunate to have done that. My last Poplar project was last week. I was in Charleston, South Carolina, and for 12 years we've had a phytoremediation project just outside of Charleston, and we were looking at remediation with a poplar planted buffer and natural remediation, attenuation of the native forests from an industrial plant in World War II that's still leaking volatiles into the estuaries. So still at this, and do the math, but I'm still here as a Poplar and Willow person, and I've met people all over the world, and Patricia's absolutely right. The Poplar community is small, and so you meet friends all over the world, and they're lifelong friends, and it gets in your blood, and so we're still doing it. And speaking of that, Reine Stettler was a big part of my career, and he's here along the Snoqualmie River. He's a University of Washington professor who was a mentor of mine, brought me to Seattle in the 80s as a visiting scientist. I've worked with him ever since, and he and I take field trips every year. He's not going to as many meetings. He's in his late 80s. But my wife says to me when we get together, when Reine and I get together, that she's not going on any more walks with us because we're like a couple of dogs. We stop at every tree. So, and it's true, we do. And wherever it is, that's what we do. We take a walk in the woods. A little outline of what I have to say this evening. It's dangerous after a meal and after jet lag to give a talk, but we'll do the best I can. I'm not giving a scientific paper with a bunch of molecular genetic terminology, or am I giving any kind of a scientific results and conclusions type paper. But I traveled around with this Poplar business all these years, and I have collected quite a few photos that I think you might find of interest. We're putting together a photo gallery in connection with that book. And it's going to be on the web page of the FAO in Rome after this meeting we're having there this fall. So here's what I'm going to cover: historical review, and my mentor that Patricia mentioned, he's still alive in San Antonio, 92 years old. His name was Phil Larson. He was the first pioneering scientist in the Forest Service, and he was a very dedicated researcher that I owe a lot to. Some of you have met him. And he always read the literature back into the early German work, into the Russian work. He felt that knowing the past really helped you learn what to do, lessons learned for the future. And when you think about it, the scientific method, you do a literature review, You go what is learned about something and you form a hypothesis and you go from there. So knowing what happened in the past really is quite helpful. And as Yogi Berra says, as I go through this, you're going to feel like deja vu all over again. And I think at the end, you probably will know what I'm talking about. Well, environmental applications are not new. The third dynasty over in Mesopotamia was doing riverbank restoration with poplar. They were doing charcoal for cooking. This is what it looks like over today. Notice the human influence, but look how resilient poplars are coming back naturally, even in a area that has been degraded. In ancient China, there's been archaeologists have found a city in the northwest desert region where they did roadside plantings and street plantings of poplars, and also there's evidence of cooking and heating in the digs in this complicated name that none of us can, maybe our friend here has a Chinese background would know how to pronounce it, but that was in the 700 BC area. And Chinese poems speak about poplar growing and poplar along streets dating up to 10,000 years ago. And in Xi'an, which is a more modern city, back in 600 AD, there were roadside plantings and amenities in cities, in that city. And again, it was cooking and heating. And this China, by the way, has the most poplars planted compared to all the other countries in the world. If you combine all the other countries' world's plantings, it does not reach how much China has. These are some areas where these are shelter belts in the west. They use it in agroforestry, and those of you who have been to China notice that poplars are everywhere in the landscape with the small farms. They have very small acreages and areas, and they get the most out of their poplars for shelter and for animal protection. And even a lot of the polluted waterways have streamside plantings of poplar and willow. The North American tribes in what it was Mexican territory in those days, but it's now Arizona, we're doing soil stabilization and irrigation with willow and poplar stakes. This has all been verified by archaeologists. And Father Kino came from Spain in 1691 and founded this mission south of Tucson, Arizona. It's there today still. And this is the Santa Cruz River and the Santa Rita Mountains. The Santa Cruz was a flowing river in those days, and the native tribes diverted water with willow and poplar stakes and also revetment type barriers so that they could do the beginning of agriculture. Prior to that, they were a nomadic group of tribes, and this was the dawn of domestication of agriculture. And here is some stakes in an archaeological journal. It shows how they did it, and they diverted water into these pools, and you can see here where the water is running now out into their field. And this is a tradition in rural Mexico that is still used by some of the peasants. Of course, all of us know about Lewis and Clark. They, in 1804, settled the West. They came out to this part of the country and spent the winter. They wouldn't have got there because they were in Mandan the first winter, and cottonwoods were important not only for the canoes that they had some damage to, but also for shelter, again, cooking and heating. And then after settling of the West, the Homestead Act of 1862 required people for their 160 acres to have a windbreak or a shelter, but that was part of their contract to get the free land. And they used the native materials, often poplars and willows. This is a little tributary of the Missouri that they might, it probably hasn't changed much since the days of Lewis and Clark. And in 1890, the Handbook of Agriculture showed a model farmstead of how it should look for those farmers to protect their buildings. That's from those days, an artist's drawing. Well, in the settlers from Europe, from Canada and the U.S., they went back to Europe, and they often took cottonwoods with them. And the cottonwood was a handsome tree, and they'd like to have it in their garden back home. And so, wouldn't you know it, there was spontaneous hybridization with the native black cottonwoods, the European poplars, and very handsome, fast-growing trees developed naturally. Putative hybrids, they call them. And they were planted for years along roadsides and in gardens because of their attractiveness. And Monet was an impressionist painting in the 1850s up to about 1912, and he had poplars as his the subject of many of his paintings, hundreds of them. There's actually a book about Monet's poplars, and he also had, if you remember, Monet had the haystacks as one of his series. And interesting story about Monet, because he lived in Giverny area in France, and the community wanted to sell the poplars that were the subject of his paintings, and he was in the midst of some paintings. And they wanted to sell it for fuel or for wood, and there was going to be an auction. And Monet talked to one of the merchants, and he and Monet bought the poplars so he could keep his work. And then after his paintings were made, then he did sell it to this merchant partner. So he was a poplar owner, and not only just an artist. And if you ever have a chance, there's quite a few of his poplar paintings in the American museums all over. If you can look on the internet, and there's many of them in the U.S. with poplars are the subject. Well, in 1912, Augustine Henry, he was at the Kew Gardens. He was the first one that artificially crossed this spontaneous hybrid. And so in the Kew Gardens, they started crossing hybrids, and the growth was so handsome and fast-growing that it caught on. And there were plantings everywhere, so that some of the American and Canadian geneticists, and I've been in the business a long time, I met these people, Heimberger in Canada and Schreiner in the northeastern United States, working for Oxford Paper, made hundreds of crosses of all the native species, and also with the European species, with pollen from there. And they've produced thousands of poplars and put them in trials. And then their work was that was in 1929. Their work caught on with these trials. They selected the better ones. And then World War II interrupted their plans for distributing those. And then in 1952, Schreiner went to Europe and spent a sabbatical for about 6 months looking at all the European poplar growers and interviewing the geneticists and the poplar growers there throughout the countries, because most of the countries had a poplar institute. In 1939, Mussolini, for all of the things bad that he did, was involved in establishing the Poplar Institute in Casale, Monteferrato in the Po Valley. And the International Poplar Commission was founded in 1947. And the reason for all this work was not environmental applications. There was impending shortage of wood after the World War II. And there was even a fuel shortage. And my parents, of course, went through the days when the fuel was, had to get a stamp to get fuel in World War II. So World War II was an important milestone for poplar. And pollen from the International Poplar Commission was sent worldwide for genetics programs in other parts of the world. How do you like this one? This is in the Hawke's Bay, North Island of New Zealand. This is one of the poplar breeders from New Zealand, Alan Wilkinson. And another breeder by the name of Van Krynard came from South Africa, where he was breeding poplars for the match industry. The match industry is huge in the southern hemisphere, so there was a huge development in South America, in South Africa, New Zealand, and Australia in those days. Again, for the wood. That's a Populus deltoides cottonwood. It's unbelievable. Well, the bioenergy timeline. We're here to talk about bioenergy, but I can tell you this, 1973 was a bad year for oil because it wasn't just expensive, you couldn't get it. It was October 17th, 1973, and we couldn't get, the gas pumps were closed. So I was at a meeting out west, my colleague and I were driving, I think we were in the Denver area, and on the freeway, and we needed gas. It was too bad. There was no motels, no gas stations, no opportunities. So we spent 2 days in the vehicle at a gas station, truck stop, waiting for gas to be delivered, October of '73. That was in the Nixon era. And President Ford followed Nixon. We all know that's tragedy. He suffered badly from the oil embargo area, and Ford did. And then, of course, he lasted 3 years, and then Jimmy Carter was inaugurated in 1976. Well, Carter found out after the demise of 2 presidents that we needed to do something about energy. So he founded the Department of Energy in 1977. And if you ever want to learn about this, go to the Carter Museum in Atlanta. It's unbelievable how much about his, he was a one-term president, but he did so much for energy. He was a nuclear engineer on a submarine. He was one of the officers of the first nuclear submarine, so he knew about energy. He was a scientist, basically, who turned peanut farmer and eventually was the president. So quite a story. Well, soon after the Department of Energy was founded in the Carter era, came the International Energy Agency in Europe. It's a consortium of energy groups. I think it's in Austria where the headquarters is. And then the Short Rotation Woody Crops Group and DOE was founded. And there's some interesting articles from the Oak Ridge group, Jack Ranney and Robin Graham and Lynn Wright, who were very instrumental in founding the Short Rotation Woody Crops Group and DOE. And then came the Biofuels Development Program at Oak Ridge. One of our colleagues here is from Oak Ridge, and so that started in '78. What was wonderful about that is they provided funding to a lot of us for many years. A lot of us in this room got money. So there was a continuity of funding coming from DOE for biofuels work with woody crops. And it wasn't poplars and willows only then. They looked at all different species. And we had contracts to study those. The Wood Energy Forum was hosted down in Nashville In '83, I was there, and we talked about then how we could convert fuel from woody crops and what was the energy equivalent. But also we looked at that meeting, kind of a startling factor that when you spend money going across the field with diesel fuel, or you build a tractor with the steel, you're using a lot of energy to find bioenergy, and the way that you really store energy in the long term is if you build it in the soil carbon in the soil. Isn't that right, Mark? There's a guy that knows about soil carbon back there, Mark Coleman. And also Jerry Tuscan at Oak Ridge wrote a paper in 2000 in the Forestry Chronicle, and it still stands today as far as I'm concerned, but one of the top things that he mentioned is you need to have wood that's stored for a long time in solid wood or in reconstituted products, not turning over, in order to make a real benefit from the carbon. The yearbook of Ag featured biofuels in 1992, and the whole book was about that. And then the short rotation woody crops operation group started in '96. They're still active today, are very active. They're working on the operations side of woody crops, and they're doing a lot of good things. Go to their website and take a look sometime. And then in 2012, the Handbook of Bioenergy Crop Plants was produced. It's about that thick, and there's quite a lot in there about woody crops and the potential. And then, of course, here we are today, still talking about it. So this is not new either, is it? And then, so after all this work, it's interesting that poplar and willows surfaced as one of the most potential crops. And they talk about eucalypts, but that's not very, it doesn't not have a very wide extent in the U.S., South Florida or parts of California, Arizona. So really poplars and willows are the ones that seem to have the widest use in this country, in North America. So why did poplars and willows come to the top, so to speak? After all this work that I just mentioned was going on with the continuity of funding from the USDA, the DOE, and all the associated universities. Well, the growth rate was superior to all the other crops we looked at, the woody crops. And leaf area is, if you're a physiologist, leaf area drives growth rate. Leaf area is the closely related to crop production. And then leaf area is also what takes up water, and that's what we're going to be talking about at this meeting with remediation and water treatment and storm water treatment, et cetera. Then poplars and willows are easy to propagate. They root readily in most cases, not all, but most. They have root characteristics that are favorable. The size and number are quite amazing. Recently, the biochemistry, to me, is just phenomenal what they've found. I mean, poplars have the innate ability in their biochemistry to break down volatile compounds from contaminants to non-toxic compounds and release them in the air just through their normal processes. And then they also have endophytes in their system that are also useful to helping growth of plants in the field. A lot of this work is being done at the University of Washington by Sharon Doty and the group, and it was originally under Milton Gordon, her predecessor, her mentor's tutelage that this work was done. The ease of culture has been a huge importance for poplars and willow. They clone easily, which has led to a lot of biotechnology discoveries. And they tell me, I was just talking to Tim Choplinski there at Oak Ridge, there's just a huge potential for biofuels with some of the new potential markers they're finding on the poplar genome for low lignin, fast-growing trees and other processing-related factors that with this new genetic information that we have on poplar. The first tree that we did the genome on, thanks to Jerry Teskin at Oak Ridge and his group there and also in California. And so there's a huge potential there. Then the crossability was the thing that originally gave us the fast growth and handsomeness back in the days of the early settlers. I mean, that was done naturally then. Now we do it artificially. And hybrid vigor, which is enhancement over the parents, is something that poplar has just a propensity for. And it's, I think Brian would agree, I mean, hybrid vigor is one of the keys to improving growth rate and other properties. And then adaptability over a range of conditions. I mean, poplars occur on every stream in the United States almost. Willows right there with them. And so they're just so well adapted. Cottonwood has just a huge range from the north of Florida all the way up into Canada and all the way west to parts of the Midwest and the plains. Talk about leaf area. Here's a 1-year-old group of plants in a remediation project in British Columbia. This is a project in Swedish Match in Brazil. This is about a 2-year-old hybrid poplar in Brazil. This is Elena Machado. She's a scientist there working on pathology. Tim knows this guy, Rich Kopp. Look at the leaf area on these willows grown. This is in Syracuse, where Rich and Tim and colleagues did a lot of work on genetics of willows. And they have a lot of them available for use. Rick Hall, he's from Iowa State. A lot of you know him. He is involved here in a phyto project in central Illinois, where PCBs were scattered throughout the landscape, and we planted poplars and willows on this site on a phyto project. How about this taproot of hybrid poplar in the Po Valley? I don't know this man's name, but this is in the archives of the Casale Monfrenar, the Institute of Poplar in the Po Valley. And some people don't think poplar's roots go very deep, but the answer is it depends on the system. How about this poplar root in India? Adaptability. How about this one on Lake Michigan on these sands? How about this guy in a limestone cliff in Wisconsin? How about the Badlands of South Dakota, where nothing grows except a few poplar and some grass? Who says that cottonwood don't contain metals or take up metal? Lou Lick knows where this is. It's right near his home. I love that picture. But here is the winner, and the timely could not be any better. Excuse me, one more. This is a saline dry area in China. That's Euphratica poplar. It grows in the worst conditions you can imagine. No water and saline. But willows grow well in saline too. But here's the all-time winner slide of this presentation. This willow took a direct hit in Hiroshima. And Secretary Kerry is there today, dedicating Hiroshima. And one of our colleagues in Japan sent this slide, gave me permission to use it. Of course, it was blown to smithereens, but it resprouted, and it's there today, this willow on the Hiroshima. Okay, I don't have much time left, so I want to show a few more pictures. This corn crop in Inner Mongolia would not be there without this shelter belt of poplar. There's so much wind in the shallow soils, they couldn't grow a crop without it. This is in Oregon, and it's up near the Washington border. This is a riparian buffer to buffer the salmon stream from the crop. This is up in Fort McMurray, oil sands mining, and they're using aspen and balsam poplar to reforest those mining areas in Canada. This is in Wisconsin. Poplar is used to irrigate the wastewater from this industrial plant, which is a little bit high in contaminants. We're using to irrigate poplars. And this is an all-time winner as far as I'm concerned in Enköping in central Sweden. The wastewater from the treatment plant is irrigating these willows. There's a buffer along this stream. The willows are harvested for wood. The wood goes to the heating plant and heats the town. I mean, talk about integration of bioenergy and a wonderful system. Lou knows where this is. It's a landfill, and we'll hear more about that tomorrow. What about animal feeding? The smell and the dust from animal feeds, the neighbors. There's all kinds of lawsuits in farm country, and so poplars can help with the smell and the odor, the dust, and also you can use animal waste and the lagoon water to irrigate them. Amenities, here's China. There's the Olympic Stadium. Look at all the poplars and willows there. That's called the bird's nest, and the last Olympics there. This is in Victoria, BC. Beautiful sort of a roundabout area here with upright columnar poplars. Let's don't forget agroforestry. It's number one behind cooking and heating is still the number one use in the world of poplars in developing countries. It's still the top use. After all this industrialization, the small farmers in these countries use it every day. And agroforestry, that's turmeric growing in India under poplar, a spice that's on the market. Okay, these are all on the program here, but I just want to say one thing about riparian buffers. The others we're going to talk about at this meeting. But riparian buffers, we forget about. And the USDA has a program. I'm involved in it. I have land in Iowa. I signed up for it. We're planting poplars and willows on stream banks. We're getting cost share to put them in there. There are hundreds of thousands of acres being planted. Poplars and willows are part of that. You get a payment for the establishment costs, and you get a payment if you take the crop out of production. And it's all in the spirit of improving the Gulf of Mexico. So, and there's a sign up today if you want, or not today, the offices are closed. Tomorrow you can go sign up for it. You have to take your crop out of production and then go for this program. So that has huge potential, and we talk about no money for ecosystem services. Well, there is in the USDA program, and the American public is paying for it. And let me just say this, look at that, oil costs, how that's fluctuated over the duration of what I've talked about this evening. I mean, in 72, it's the same price as it is today, but look at the spikes that you all know about. And this is another thing I wanted to talk about that we really need to worry about when we're making the posters here, is the producers and landowners that I work with now. I'm no longer in basic science. They need a market. And if there's no market, the nurseryman has to put money into his nursery. The landowner has to take land out of production. There's no market. They're not going to do it. Now, if there's no, and if there's no material, there's no market. So this is a dilemma we have, I think, to solve at this meeting. climate change, I was involved as the principal investigator in a group funded by DOE in Washington. We fumigated aspen and other northern species for 12 years with high CO2. The growth rate increased at first, but then it used all the nitrogen up in the soil. So what did we find after 12 years of research and multi-millions of dollars of CO2 that we spent with the DOE budget? We found a huge increase in pests and diseases in the trees. And so this is something that we may be facing in the future. My last slide is this: the continuity of funding for tree improvement. A lot of the stuff you saw today, these trees were produced in the 1940s or 1929, or even in the 1800s that we're using. Contrast that to crop plants. Every county in Iowa has a variety that does better, and everything is genetically engineered. We're in the dark ages with our tree improvement. And how many of these programs? There were 4 in Wisconsin where I live. There are none now. There was a genetic institute on Aspen. There was one in Madison. There was 2 in Rhinelander. They're gone. In Iowa, there's a small group. There's some work going on in Minnesota and Oregon. Canada's down to 1. And of course, in Willows, the Thames group in Syracuse and some private growers are still, and they're starting a group down in Mississippi looking at black willow. But think about this. We are not improving the materials like we should be compared to our competitors in other crop fields. And when you work in the field like I do, in practical side, you're not finding enough new material to put out there to do the job that we need. Thank you very much.